students getting grade, last name getting G, H, and I. G, H, or I, any grade come down for their retakes. Thank you.
Okay, so we're going to look at solving by taking perfect squares or difference in perfect squares. So again, first thing, we're going to look at the opposite, starting with our factors. We're going to multiply them out. In this case, we have x plus 4 times x minus 4. Again, if we use our FOIL method, x times x is going to get us x squared. X times negative 4 gets us negative 4x. 4 times x gets us a positive 4x, and 4 times negative 4 gets us negative 16. And then when we combine our like terms, notice our middle terms are opposites of each other. They cancel out, and we're left with just our x squared minus 16. So this is what we're going to be looking at. We're going to be factoring it to go back into this method. We can also have terms with values greater than 1 in front of our exponents or in front of our variables. So we've got 5n plus 1, 5n minus 1. Again, when we FOIL it out, we're going to get 25n squared minus 5n plus 5m and then minus 1. Again, those two middle terms, they're going to cancel each other out, and we're left with just our 25m squared minus 1. So even if we have numbers in front of our variables or our coefficients, they can be perfect squares as well. So 25 is a perfect square, 1 is a perfect square. So that's what we're going to be looking at. And again, our last example, we have two variables in this case, 2a plus 3b times 2a minus 3b. Again, the exact same thing is going to happen when we FOIL this out. That middle term is going to cancel out because we have the same values, one positive and one negative. So 2a times 2a gives us 4a squared. 2a times negative 3b, negative 6ab. 3b times 2a is going to give us a positive 6ba, or we can say ab. This can be reversible. And then 3b times negative 3b is going to give us a negative 9b squared. And so our middle terms, again, are going to cancel out. So even though I did ba, we can rewrite it as ab. So those two things cancel out, and we're left with that 4a squared minus 9b squared. So again, all of these are what we call perfect squares. And we can factor those very easily kind of using this method. So they all kind of fall under this same branch. We have some value squared minus some other value squared. The way we can factor these is we're going to take the square root of both of those, and then we're going to put them into the pattern of a plus b and a minus b, which is what we see up here, right? Take the square root of x squared, that gives us our x values or our a values that we plug in. We take the square root of 16, we get 4, that would be our b values. Same thing with our second equation, 25m squared, take the square root of 25, we get 5. Take the square root of m squared, we get m. That's our a value. Plug those in. Take the square root of 1, we get 1. That would be our b value. So we can use that pattern to factor all of these perfect squares or difference of squares. And again, you can always check your work just by multiplying it right back out to see what you started with. So let's look at a few examples. Number 1, we've got a squared minus 4. Again, first thing we'd always need to check is, do we have any GCFs? Do we have a greatest common factor among these two? No and no, right? We have a's here and a number there. Can't take anything out. So I'm going to say a squared is a perfect square, 4 is a perfect square. So the way we're going to solve that, take the square root of our first. It's going to be a. have our plus and our minus on the inside. Take the square root of our second number, 4. We're going to get 2. Number 2, we've got n squared minus 64. So again, no GCF in this case. So we can go ahead and set up our parentheses. Again, take the square root of your first value. Square root of n squared gives us n plus minus square root of 64 gives us 8. There we go. We have factored that difference of perfect squares. Again, you can always pull it back out. N times n gives you n squared. N times negative 8 negative 8. N 8 times n gives you positive 8n. Those two cancel out. 8 times negative 8 gives you that negative 64. So pick a couple more from this page for our examples, and we'll do those as well.
Is there any certain one that has GCF?
There is one that, no, I don't think so. On the back page we do. We do have a prime one on here. So number 5, k squared plus 25. So even though k squared and 25 are both perfect squares, notice our value in the middle is a positive. We cannot factor this. This is a prime example. Okay. Again, it has to have that negative in the middle for it to be a difference of perfect squares in order for us to solve. Okay. But on the back page, we do have some with the grade or GCF, greatest common factor, that we need to take out before we can do our difference of perfect squares. So like number 21, we've got 2n squared minus 72. So it would be the greatest common factor of those two. 2, right? 2 and 72 are both divisible by 2. That's going to leave me with an n squared. 72 divided by 2 gives me 36. My 2 I'm going to leave out front. And then I'm going to take the square root of both the insides. So square root of n squared gives me n. Or plus or minus the square root of 36. 6. There we go. Okay. So it's just adding on one more step, that GCF at the start. We always want to check for GCFs, see if we have any, and take those out before we do our factoring. So are there any of those on the back page you want to look at? Anybody lost, confused?
28.
28. 28, we got 36 p cubed minus 9p.
Oh, wait, you're looking at 29.
Oh, I was looking for 9. Did you say 28?
Yeah.
8x squared minus 32y. Okay, so first thing we need to take out is our GCF. So what number can we take out of both of those? 8. What variable can we take out? No 1. So that's going to leave us with x squared minus 4y squared. Okay, so the next thing, our 8y is going to stay out front. X squared is perfect square, 4 is, and so is y squared. So we can take the square root of each. The square root of x squared is x. That's my first term. Throw in your plus and minus. The square root of 4 is 2. And then the square root of y squared is y. Okay. And again, you can always spoil it back out. Check your work if you want to. Any others? Any other questions?